All right, chemistry kiddos, we are going to do a quick lesson on how to balance an oxidation reduction reaction that takes place in an acidic solution. So lesson one will be how to do it in an acidic solution, and lesson two will be how to do it in a basic solution. So first things first, this will only make sense if you know how to assign oxidation states. So you need to make sure you review your notes on how to assign oxidation states, and then being able to split a reaction into half reactions. And so there's notes that you should review before you start trying to do this. And you have practiced this week in your book, your textbook, page 867. There's a couple problems assigned to you, and this is how you're going to basically do those problems, okay? So again, the first thing is make sure that you know how to assign oxidation states, so make sure you review how to do that. Oxidation states, same thing as oxidation number, okay? And then also have this out, the steps on balancing a redox reaction in an acidic solution, and on the very back of that, you have steps to balance in a basic solution. So today's lesson, this lesson right now, is going to be on acidic solution, and then we'll come back and do another video and do a practice one in a basic solution. But basically, essentially, the basic solution steps is essentially the same steps as an acidic solution, and then at the end, there's a few more steps you have to follow. So essentially, it's the same idea. So if you know how to do the acidic one, then the basic one is just a couple more steps after that, all right? So let's get into this, all right? And again, you have to know what oxidation reduction is. You have to be able to assign oxidation states. So until you can do that, you might want to wait on this lesson, okay? All right, so here is our practice problem, all right? So here's our reaction, okay? So it says a dichromate ion in an aqueous solution plus an iodide ion in an aqueous solution yields chromium 3 plus in an aqueous solution and iodate 1 minus in an aqueous solution, all right? So we look at this, and on the AP exam, if you were asked to do this, they would tell you that you have an acidic solution. In your textbook, I think it just says right next to this equation, it would say acidic or basic solution, all right? Regardless, right now, this is an acidic solution, and if it was a basic solution, we'd be following essentially the same initial steps, and then we'd have to do more steps at the end, okay? So here is our oxidation reduction reaction, and if we're not sure if it's an oxidation reduction reaction, we can assign oxidation states and see if any of them change, and if they change, it's gotta be redox, okay? But let's talk about what it means to be in an aqueous acidic solution, all right? So this means you have a lot of H+. When it's acidic, you have H+. That's what acidic solution means. You have an excess of H+. And we'll get more in detail about what it really means to be in an acidic solution when we get to Unit 5. But right now, I just know you have, hey, there's some H+ in your solution too. So not only do you have all these ions, right, floating around, you got H+ in there too, okay? And then remember what aqueous means. It means surrounded or mixed with water. So you got a bunch of H2O floating around too. So there's H+ in the beaker, and there's H2O in the beaker as well. All right, so that's something to note, all right? So the first thing we're gonna do is assign oxidation numbers to everything, okay? And those are the numbers I have circled up here. So if you don't know how to do this, you need to go review the notes on how to do it. But essentially, the chromium in the dichromate ion is a +6. So each chromium is a +6. Oxygen's a -2. The iodide ion, that's easy. The charge is -1, so that's its oxidation state, -1. The chromium ion, that's easy. Its charge is 3+, so its oxidation state is +3. And then in iodate, the oxygen is -2, and the iodine is +5. So if we look at this, the chromium went from +6 to +3, So its oxidation state decreased or reduced, and the iodine went from -1 to +5. So the oxidation state of iodine actually increased, okay? So chromium is what undergoes reduction. So if you were asked for the oxidizing agent, it's chromium, because remember, the word agent means opposite. So chromium is reduced, so chromium is the oxidizing agent, okay? But chromium is in the reduction part of the reaction, okay? Chromium is reduced, all right? It's going from +6 to +3, okay? And then iodine is being oxidized. It's going from -1 to +5. So if your oxidation number goes up, that's oxidation, and if your oxidation number goes down, that's reduction, okay? And so the reason why we want to assign oxidation states is because we want to know what is oxidized and what is reduced. So we discovered it. Iodine is oxidized and chromium is reduced, okay? Because what we're going to do from there is we're going to write our half reactions. So the two half reactions are oxidation and reduction. So oxidation reduction reactions, you can split up into the two separate processes. Oxidation, which is the loss of electrons, and then reduction, which is the gaining of electrons. So now what we're going to do is split this up in our two half reactions. So I like to do oxidation and then reduction, but it really doesn't matter. You could do the reduction half reaction first, then the oxidation half, or vice versa. I like oxidation and then reduction, okay? And I'll kind of explain why as we go through this, all right? So the oxidation half includes whatever got oxidized and whatever it becomes. So the iodine is oxidized, and this would be the first part of the oxidation half reaction. So I- yields iodate, okay? So that's our oxidation. It's the bare bones oxidation half reaction. Obviously it's not balanced, right? Obviously there's no oxygen on this side, right? But we're going to follow some steps to balance that, all right? But first is just here's the oxidation half, okay? And then the reduction half is whatever got reduced, so the chromium got reduced, and whatever it turned into. So the chromium and dichromate got reduced, and it turned into chromium 3+. So this would be the reduction half reaction, all right? So this is the oxidation half, this is the reduction half to start with, okay? Now what we're going to do is focus on each half reaction one at a time. So let's look at the oxidation half. Okay, if you look at the oxidation half reaction, the first step, and again, I'm following these steps on this note handout, so you should have this out as we go through it, okay? So the first step, is to make sure everything that's not oxygen or hydrogen is balanced. So if you look at the oxidation half, all you have is iodine and oxygen, and the I's are balanced, right? There's one I here and there's one I here, so you're good. So once you know that those are balanced, now you can focus on the oxygen. So the next step is look at the oxygen. Now, how are we going to balance the oxygen? Well, remember what's in our acidic solution. We have water and we have H+. So to balance out the oxygens, we're going to add water. So if I have 3 oxygens on this side and no oxygens on this side, we have to add 3 waters, because each water has 1 oxygen, and I need 3 oxygens over here. So what we're going to do is add 3 water molecules to this side, and that balances the oxygen. 3 O's, 3 O's, okay? Once we balance it, the oxygen, by adding water, now we balance the hydrogen by adding H+. Remember, we have an acidic solution, so we got a bunch of H+ around.
No problem.
Okay. So we have to add, so notice that if we added 3 water molecules over here, that balances our oxygen, so we get 3 oxygens. But now we got 6 hydrogens on this side and no hydrogens on that side. So we have to add 6 H pluses to that side of the reaction. So right now what I want you to notice is everything is balanced. 6 H's, 6 H's, 3 O's, 3 O's, 1 I, 1 I. Everything's balanced except for one thing, okay? The one thing that's not balanced is the charge, okay? So not only do you need to have the matter balanced, so the same number of H's, the same number of O's, the same number of I's, right? But you also have to have the charge balanced. And remember, what is oxidation reduction? It's the transfer of electrons. So we're going to balance the charge now by adding electrons to one side of the equation, okay? So the reason I like to show oxidation and focus on the oxidation half reaction first is because oxidation is what produces electrons. So if we know that this was the oxidation half reaction, right, we labeled it the oxidation half reaction. When I'm finished balancing in any oxidation half reaction, electrons are going to be on the product side. So if you have to add electrons to one side or the other. But another thing that you might want to just keep with you for the rest of your life, your rest of your chemistry life, is knowing that if it's an oxidation half reaction, electrons will be produced. Electrons are going to be on the product side of the equation. So that really solves the mystery of where you're going to put them, all right? But let's look at it. How we balance the charge, okay? So this side's total charge, this is neutral. You have three of them, but they're neutral, so that's 0. But this is -1 and you have one of them. So the total charge on this side is a -1, okay? Let's look at this side. This is +1, but you have 6 of them, so that's +6. This is -1, you have one of them. So the total charge on this side is +5. So you have +5 on this side of the equation, and you have -1. Now remember, the only thing you can do is add electrons, okay? So adding electrons brings your charge down. So what you're going to do is we have a -1 on this side and we have a +5 on this side. We have to bring the +5 down to -1 to balance the charge, okay? So how do we bring a +5 down to -1? We add 6 electrons. So if we add 6 electrons, okay, now everything is balanced. The overall charge on this side of the equation is -1. The overall charge on this side of the equation is -1. You have H's are balanced, O's are balanced, and I's are balanced. All right? So this is our oxidation balanced half reaction. All right? So when I- gets oxidized to iodate, right, 6 electrons are produced. Okay? Now, where do those 6 electrons go? They are used in the reduction reaction, right? So oxidation produces the electrons, but then the reduction reaction uses those electrons. All right, so now let's focus on the reduction, okay? So again, if you were just balancing a half reaction, this is where we would stop. If you were saying, hey, balance this oxidation half reaction, this is where we would end up, okay? This is a balanced oxidation half reaction. Remember, when you have half reactions, you're going to see the electrons. When you combine the two half reactions, the electrons are going to disappear. And I'll show you that in a second, okay? All right, so let's focus on the reduction half reaction. So this was our reduction half reaction. But remember that first step. A lot of people, when they're tasked to do this, they skip to oxygen and hydrogen right off the bat. Remember, you have to first balance anything that's not hydrogen or oxygen. All right, so notice that in this reaction, we had 2 chromiums over here, but we only had 1 chromium ion in the initial half reaction. So that's why I had to put a coefficient of 2 here. And that 2 matters when we're talking about the overall charge, because this is 2 times 3 plus now on this side. This would be a total of 6 plus on this side right now, okay? So you have to have the chromium balance. So we had to put a 2 here, all right? Now that anything that's not oxygen or hydrogen is balanced, now we can balance oxygen by adding water, and then hydrogen by adding H+. So again, we're following the same exact steps we did with the oxidation half reaction, okay? So now we'll balance the oxygen by adding water. I have 7 oxygens on this side and 0 on this side, so I gotta add 7 waters on this side, right? So that balances out the oxygen. Now we have to balance out the H. I have 14 H's. I have no H's on this side, so 14 H+ on this side, okay? All right, so now everything is balanced except for, you guessed it, the charge, okay? So let's look at this side. You have a dichromate ion that has an overall charge of 2-, and then you have 14 H+. So this is 14 plus and a 2-. So this is a total of 12 plus. We have a 12 plus on this side, plus 12. And then on this side, this is neutral, but you have 2 3 plus ions. So this side's total charge is plus 6. This is plus 12. So remember, this was a reduction half reaction, so we should be expecting to put electrons on this side of the equation because oxidation produces the electrons, but reduction uses those electrons. The electrons are a reactant for a reduction reaction, okay? So how are we going to bring a plus 12 down to a plus 6? You add 6 electrons. So we balance the charge by adding 6 electrons to this side. So now everything is balanced, including the charge, okay? And this would be our balanced reduction half reaction. But then to get the overall balanced equation for the oxidation reduction reaction, we have to add the two together, okay? So now that we have our two balanced reactions, this is our balanced oxidation reaction, this is our balanced reduction reaction, and we can see, right? This process produces 6 electrons, and then those 6 electrons go to kickstart this process, okay? Now, here's the key. Before you add the two half reactions, you need to make sure that the electrons completely cancel. So the number of electrons produced in the oxidation half reaction have to be equal to the number of electrons used in the reduction half reaction, okay? In this case, it's a coincidence that 6 electrons were produced and 6 electrons were consumed. So they will automatically cancel out when you add these two together, okay? However, sometimes you might get like 3 electrons here and 6 electrons here. If you have 3 electrons here and 6 electrons here, before you add, you need to make sure those numbers are equal. So if I had 3 up here instead of 6, then I would multiply each coefficient in this reaction by 2, so I would end up with the same number of electrons. Now, if you didn't follow that, don't worry, in our next example, in the basic solution example, you'll see what happens when the number of electrons don't match after you balance the half reactions, okay? Right now they match, so we're good to go. We can balance, or we can add. So when you add equations together, if they're on opposite sides of the arrow, they cancel out, but you have to have the same number to completely cancel out. So the electrons completely cancel out. 6 electrons, 6 electrons cancel out. Now I also have H plus on this side and H plus on this side, but I had 14 on this side and 6 on this side. So the 6 on this side completely go away, but that 14 will now become 8, right? 14 minus 6. And then I also had some water on this side and water on that side. I had 7 waters and I had 3 waters. The 3 totally cancels out, and this would be end up being 7 minus 3, so 4 waters on this side. And then we just, everything that's on this side of the arrow, you write down, right? So we had 8 H pluses, we had an I minus, and we had a dichromate ion. And that yields an iodate ion, 2 chromium 3 plus ions, and 4 water molecules. And so that is our balanced equation, right? So we got our 2 balanced half reactions, and then when we add them together and make sure that the electrons completely cancel, okay, which they do in this case, all right? This is our balanced oxidation reaction. This is our balanced reduction reaction. When we add them together, we get our balanced oxidation reduction reaction. And notice that in our final equation, if you have an overall oxidation reduction reaction balanced, electrons should no longer be in the equation, okay? So the half reactions kind of suss out the electrons. The half reactions show us electrons being produced and then electrons being consumed. But then when we add them together, we don't see the electrons anymore. All right, does that make sense? All right, so that's how you do an acidic solution. I'm gonna come back with another lesson in a little bit on how to do the same thing, but in a basic solution instead of an acidic solution, okay? So we'll do another practice one here in a little bit. So you have 2 videos you can watch on redox practice, all right? So thanks for watching. Hope you enjoyed the video. smash that like button.